These notes are going to be covering how to analyze graphs. You should already have a printed out copy of the graphs as well as the information we are going to be looking for. The first part of our packet shows this particular graph of f of x, and we are looking for first the domain. Remember, domain is the value of all of our x terms, and we read that left to right, and looking at our arrows on both the left and the right of this function, we do see that they go out forever in both directions. So the domain for this particular function is from negative infinity to infinity. Also in the directions, in this particular problem, we are going to be writing all of our intervals in inequality notation. The second thing we're looking for is the range. Well, the range are the values of y, and when we read our graph, we look bottom to top. On either end of this graph, we see that the arrows are going down, so our function is going to start very low at negative y, and it's going to travel up to be at the highest point, which is right here on our graph, and that has a y value of 3. At that particular point, it is also equal to 3. It's included in our range. So our entire range goes from negative up to 3. Part C of this, we are looking for the interval where f of x is increasing. As we've looked at before, increasing intervals are where, when we read a graph from left to right, our graph is going up. So if we were tracing over this picture, starting on the far left, right, we start to trace over this picture, we'll see that we are actually going up until we hit this particular point. So that function is increasing. It is starting at negative infinity. Oops. And it is then going up to negative 2. This is negative 2 on the x-axis. Our increasing and decreasing intervals do not include our endpoints, so therefore we do not have an equal sign. We have another increasing interval. If we travel across horizontally, right, it is not increasing, but when we get to 3 on the x, and we increase for 1 unit from 3 to 4. Those are our 2 increasing intervals. Part D of this worksheet talks about the interval for f of x that is decreasing. Where we are decreasing is where we are going to go down on our graph. So again, reading left to right, the yellow went up, and then we had a horizontal piece which is not increasing or decreasing. Then we went up again, and then after this point, this value over here, from 4 on, we're actually going in a downward motion, so that is our decreasing interval. So from 4 to infinity, we are decreasing. The next part of our worksheet is asking where f of x is greater than or equal to 0. Well, when a function is greater than or equal to 0, when we look at f of x, we are looking at where y is greater than 0. Well, y is greater than 0 above the x-axis. So above the x-axis, we are looking at everything. We are looking at everything along this part of our picture. This is all above the x-axis. Whereas that's starting negative 4, and it's going out here to 5. So our function will be greater than 0 from 4 to 5. At 4 and at 5, our function is actually equal to 0, not greater than. So we do not include 4 and 5 in this interval. The next part, we're looking for x and y intercepts. No, I'm sorry, part F, we are looking first for where our function is now less than or equal to 0. So part F is asking us, well, where is f of x less than or equal to 0? Well, less than or equal to 0 is now below. This is where we're looking for y to be less than or equal to 0, which is below our x-axis, right? It's where y is negative. Where is y negative? It's two pieces. We have this piece going to the left, and we have this piece going to the right, where our function is negative. So we have two different intervals. The first one, starting at negative infinity and going to a value of -4. At -4, it's actually included because we want to know where the function is less than or equal to 0. Our function is equal to 0 at -4. Out here at 5, our function is also equal to 0. So we have a second interval from 5 to infinity. Part G, we're looking to find x-intercepts. X-intercepts, of course, as we remember from Algebra 1, are where we are touching the x-axis. And I just erased them. Those 2 points are here at -4 and here at 5. Our x-intercepts are coordinates, -4, 0, and 5, 0. Part H, our y-intercept. We have one of those. That y-intercept is right here on the y-axis, and the coordinate for our y-intercept is 0, 2. Part I, we're looking to evaluate f of 1. On a graph, when we look to evaluate a particular term, we are looking at when x is 1, what is y? So here is 1 for x. We're going to travel up and see that our y value is equal to 2. We have 2 more parts to this. J is saying what values we want to find all values of x such that f of x is equal to -3. We look at our picture. F of x equals -3. Another way of looking at that is saying, well, where is y equal to -3? We look at our picture, we want -3 for y, but yeah, 1, 2, 3, -3 for y is here. So if we draw a line all the way across, because that is the graph of the line, y is equal to -3, we are looking for the x values where that line intersects our graph. So we have an intersection here, and we have an intersection here. Travel up to the x-axis, this is 6. And if we go up the x-axis from here, this is at -7. So our x values will be, for here, that x is equal to -7 and 6. To finish off this function, we want to know what word best describes f of x from the interval -2 to 3. Well, if we look at this picture from -2 to 3, we are looking at this piece right here. This is 3, this is -2. What kind of function is that? That is considered constant, right? Any horizontal is a constant. Okay. All of those pieces and parts of our graph are all significant. Let's turn the page and we will look at number 2. Number 2, again, this is now a function of g of x, slightly different than the last one. But the first part of this, we are going to find the domain. And the second part, we are looking for our range. Domain again, left to right, we are looking at everything. This one on the left, though, as an initial endpoint. That endpoint is at -5. And if we travel all the way to the right for x, you see that the arrow continues in that direction. So we are starting at -5 and traveling to infinity. Our range, we're looking lowest value to the highest value in our range. Our lowest value, we start bottom, -infinity, work our way up. Our lowest value is right here at -4. So our range is starting at -4 and including -4, and it continues on to infinity because the arrow on the right will continue to increase forever. Part C, we are looking to find out where g of x is increasing. Again, we're going to trace over our picture to find out where our function is going up. So starting at the left, from -5 down here, it's not increasing. We don't increase until we get to this point and start going up in this direction. So our increasing interval from x to this point here at 0, that is our first increasing interval. So we have from -3 to 0 as our first increasing interval. After that, we do have another piece that's increasing. It's over here on the right. And this piece starts at 4 and increases forever. So our second interval starts at 4 and goes to infinity. Our next part D is we are looking for where g of x is decreasing. Decreasing intervals are where we would draw and go down. So that happens the first part of our graph, starting at -5, we're going down in this direction. So from -5 to -3, we are decreasing. After that, we decrease again for this second piece right here from 0 to 4. Part E, we're looking to evaluate where g of x is greater than or equal to 0. Again, g of x being greater or equal to 0, we want to know where y is positive. That's what that expression is saying. Where is y positive? Y is positive above the x-axis. We look at this picture above the x-axis is here and here. And since this says equal to, we are also going to include that number where it is equal to 0 at -5. So we actually have 3 pieces here. We have where x is equal to -5, and then we have from -1 to 2, and then again from 6 to infinity. Okay, so there are 3 specific intervals where g of x is greater than or equal to 0. Part, excuse me, part F. Part F, we want to know where g of x is now less than 0. So now we're looking for where it's negative, but not including 0. So where it is negative and not including 0 is now below the x-axis. So this whole piece and this whole piece. Not including 0, we have now 2 intervals. The first one starting at -5 and going to -1, and the second one starting at 2 and going to 6. Part G, x-intercepts, and part H, we're looking for our y-intercept. On our picture, x-intercepts are where we are touching the x-axis. In this case, there are 4 of them. They are -5, 0, -1, 0, 2, 0, and 6, 0. Our y-intercept on the x-axis up here at 0, 2. Part I, evaluating g of x at 12. Well, if we look at our picture, we see that 12 is beyond this graph. This only goes up to 1. This only goes up to 10. We want 12. We can do this a couple of ways. We can just continue on evaluating our slope, whereas 11 and 12, where they would be based on the slope. If we know the slope of this line is 1, at 10, we would be up here at 4. At 11, we're going to be at 5, which means 12, we are going to be up here at +6. Okay, so again, just extending that line, it is beyond, but we can extend that line and evaluate. Part J, we are looking for x such that g of x is equal to -3. So in a similar way, on like the last one, we are going to look at -3, which is 1, 2, 3, y equals -3 is down here. Evaluating where y is equal to -3, we have 1. Oops, that's -2. I apologize. I'm going to go down one more. This is -3. So -3, we actually hit the graph in 2 different places, when x is -4 and when x is -3. Right, we come up here, this is -4, we find the corresponding x here, and that's -2. Okay, so -4 and -2. Okay, looking at m of x. M of x is not on our picture, but we can express or find m in terms of g. We want to find m of -1. So what we're going to do is we are going to take this -1 and we're going to plug it in here for x. Right? This is going to become a -1. So when we find m of the -1, we are looking to evaluate g of -2 and add 3. This we can find on our graph. We go to -2 on our graph. This value is actually equal to -3. That -3 then gets multiplied by a 2, and we add 3 for a total of -3. So m of -1 is equal to -3. This notation, this is 2 times g of our function, and in this case it came out to be -2. We evaluate that from the graph, and then we use that number to find our function value. The last question on this particular page deals with average rate of change. Average rate of change, as you know, is evaluating simply our slope. So part L, I want to find our average rate of change on the interval -2 to 1. So our average rate of change, we are looking for a slope, but we need our 2 particular points. So the first thing we're going to look at is, well, at -2, when x is -2, go to our picture, what is y? And it is here at -3. On the other endpoint of our interval, at 1, we find that this point here at 1 is equal to 1. So those are our 2 coordinates. Now our average rate of change is calculated by subtracting our y's over the difference in our x's. This comes out to be 4/3 as our average rate of change. This concludes question 2. Now for question 3 and question 4, we'll be looking at interval notation. So the previous notation was inequality. Now in number 3, we are looking at interval notation. Similar questions as before, but a different graph and different notation. Part A, looking at our domain of this function. Our domain left to right, see that this is opening up in both directions forever. So our domain interval notation would be from -infinity to infinity. Our range, our lowest value is at 0, and it goes up. So our lowest value is 0, and it's included, right? We have a closed circle there. And now what is our highest value? It is not this middle peak. That's not our highest value. Since we do have arrows going up in both directions, our range actually will increase all the way up to infinity. Our x and y intercepts are next. Our x-intercepts, looking at this graph, they will actually be this point here and this point here, corresponding to -3 and +5. So -3, 0 is one intercept, and 5, 0 is the second intercept. Our y-intercept at the top here, is up at 0, 7. Looking for the next part, we're looking for where our k of x is increasing. And again, travel left to right on our function, and we're going to look for where we would draw our pencil markings that would be going up. So left to right, on the left, we were actually drawing down to get to this point until we get to the -3, and then we start to draw up. Then we draw down again, and then we draw up again, starting at 5 and going up. So we are increasing First, from -3 to 0. Interval notation. We are increasing from -3 to 1, and then again from 5 to infinity. Our next question is asking us where k of x is decreasing. So we're looking to see, well, if we were to trace over this picture, where are we going down? We're going down on the left, starting at the left, and then we'll go down again in this middle piece here. So there's two intervals where we are decreasing. First, starting off at -infinity to -3, and then again from 1 to 5. These are both two different decreasing intervals and two different increasing intervals. Part G and Part K, we're going to evaluate where our function is greater than, G and H, where our function is greater than or less than 0. So Part G, I want to know where k of x is now greater than 0, not including 0, just greater than 0. Looking at our picture, everything seems to be above the x-axis, except for two particular points. At this point here and this point here, which is 5 and -3, those two particular points are where it's actually equal to 0. So we don't want that as part of our value greater than. So we do need to break this up. So the first interval where we're greater than 0, this piece here is from -infinity to -3. Then again, it's going to start and not include -3 and travel to 5, and then again skip over 5 and increase from 5 to infinity. Looking at where k of x is now less than or equal to 0, we can look at our picture and see, you know what, there is nothing that is less than 0. However, we do have two values where it is equal to 0. So the two values where we are equal to 0 are at -3 and 5. So at -3 and then at 5 satisfies where k of x is less than or equal to 0. Part I, we are looking to evaluate k of -1. K of -1, we're going to go to -1 on the x-axis, travel up. What is the corresponding y for this coordinate? And it is 4. So k of -1 is equal to 4. Part J, we want to find all x such that k of x is equal to 1. So as we've done in the last two examples, we're looking to see where k of x equals 1. That is a horizontal, we're going to graph now a horizontal line across here at 1. And find that we're actually hitting this graph 4 times. 1, 2, 3, and 4. Those 4 particular x values are where k of x is equal to 1. So starting on the left, lowest one is -4. And then we have -2. And we have +4 and +6. Okay, last but not least, we are looking for average rate of change over the interval -1 to 3. So as we did before, we are looking to find the coordinates associated with those 2 points. So when x is -1, look at our picture, -1, we are here at +4. And the second part of our interval, our ending point, 3, which is here, our coordinate is also at 4. Average rate of change is to evaluate the difference in our y's over the difference in our x's. And we find that we get 0 over 4, which is equal to 0. So our average rate of change equals 0. Okay, our final example, number 4, a graph of h of x. And starting with, again, domain and range. Left to right, this domain right over here on the left is an open circle. So that value is not included in our domain. And so our domain starting on the left is actually an open bracket at -6, but it does continue on forever and will go off to infinity. So this is an open circle at -6. Our range, starting since this end, this arrow goes on forever down, our range is actually going to start at -infinity, and it travels up to a positive value of 4, where it doesn't go any higher than that, and 4 is included. Part C and D are x and y intercepts. Our x-intercepts, looking at our graph all the way across, we can see that there's actually only one intercept here at 5. But notice since I extended this line out here, we have a second x-intercept. Not everything is always going to be on the picture. You do have to go a little bit beyond. So our first intercept is at 5, 0. The second one, if we extend this line, this actually is at 11, 0. Again, extending the line using the slope, you can find those answers. Our y-intercept, nicely up here at 4, our coordinate is 0, 4. Part E, you're looking for the interval where h of x is constant. Remember, constant is a horizontal. The horizontal piece that we want to look at, look at a picture, I'm just going to erase some. You can see the horizontal. We actually have this happening in 2 different places. We are horizontal here and here. So there are 2 places or 2 intervals where we're at a constant. The first one from -5 to -3. And then again from -2 to 3. Part F, we want to know where h of x is increasing. Looking at our picture, increasing means going up. So starting on the far left, where are we going up? We're going to trace over it. We're going up here from -6 to -5. So there's our first piece. We are going up. Traveling along the constant, that's not increasing, but then we're going to increase again here from -3 to -2. And then, of course, we're going to increase one more time out here on this part of the curve from 5 to 7. Part G of our worksheet is asking us to find where h of x is decreasing. And where it's decreasing, it is going down. And that actually happens in two different places. The first one here, that left of that U shape from the increasing, and then after that increasing piece, this whole last decreasing line. So our first interval is from 3 to 5, right? That's this one, 3 to 5. And our last one is 7 to infinity. It goes all the way to the end. Part H, we are looking to see and find out where h of x is now less than 0. So not including 0, but where is it less than 0? Where is this picture ever going to go underneath the x-axis? Well, that's going to be out here. We extend this line more, we will go below the x-axis at this point starting at 11. So our function will be less than 0 starting at 11 and going to infinity. Okay, it doesn't include 11 because we just want to be less than 0. Part I, where is h of x less than or equal to 0? Well, less than or equal to 0, what are we including in this 11 to infinity? And that is the 11. So we're going to, include the 11, but also include the 5. It is equal at 5, and then again at 11 to infinity. So you do have to be very careful with those brackets to include it. All right, part J, average rate of change over the interval from 3 to 7. So we are looking for what values on our function are associated with 3 and 7. So 3 is here, 7 is here. So our coordinate 3, 4, and our positive coordinate 7, 4. Average rate of change, subtract our y's over our x's, and we get 0 over 4, which means that our average rate of change is 0. Finishing up the last two pieces, looking at some function values. Part K is asking us for to evaluate h of -6. We look at this picture, -6 is right here. What's happening at -6 is that is an open circle. That means that this actually does not exist. Okay, at -6, your function does not exist. That point is not included, therefore cannot be evaluated. For part J, we want to find all x such that h of x is equal to 1. Let's pick yellow. So looking at 1, we will graph y equals 1 right here. And what values do exist for x? Not at -6. Remember, that's an open circle, so that's not part of it. So this value is included, this value is included, and a third value here all the way at the end. So the three values of x are 4, 6, and 10. Last but not least, this is an L, by the way. Part M, we are looking to evaluate h of 14. To go off of our graph to get h of 14, And I'll extend this a little bit. This is a slope of 1. This value is 10. So we have 11, 12, 13, 14. So at 11, we're here at 0. So 12 is going to be negative 1. 13 is negative 2. So 14 is going to be here at negative 3. That concludes this packet for analyzing graphs. You can now finish up your homework packet and analyze a few more graphs.